This is graphing the tangent function with both a phase shift as well as a change in period. So let's go through the equation that's given here and let's pull out the pertinent information so we can get this graphed. So first of all, we have an A value of -2. And remember what we talked about in class. Having an A value of -2 is going to create a reflection, and it's also going to create a stretch vertically. Now, more importantly, we have a B value of pi. So if our B is equal to pi, in order to find the period of this function, recall that the tangent parent function has a period equal to 1 pi. So if our B value is pi, our period is going to be pi over pi, which is equal to 1. So the period length here is going to be 1 unit, not 1 pi, but 1 unit. We also have a C value. That C value is 2 pi. So what we're going to do is we are going to take all of this quantity and we're going to set it equal to 0. And when we take the quantity that's inside of the parentheses and set it equal to 0, it's going to give us our phase shift. Phase shift for our tangent function here. So let's solve it for x. So pi x equals 2 pi, divide by pi, and we get x equals 2. So we have a phase shift of 2. A period equal to 1, a phase shift of 2. Now, with our period so short, only 1, then let's still number our x-axis in terms of quarters. 1/4, 1/2, 3/4, 1. 1 and 1/4. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, and 12/4. So we're still numbering it by fourths. I'm also going to go backwards. -1/4, -1/2, -3/4, -1. So we have a phase shift 2 to the right and a period length of 1. Now there is no D value. Since there's no D value, then we don't have to worry about any vertical shift. So I'm going to use my handy dandy ruler so I have some nice graduated marks on my y-axis, and I'm just going up 2 and down 2, up 2, down 2, because that A value is -2. So once again, we're going to shift from the origin over 2 to the right. Recall that the parent function of the tangent has a y-intercept at the origin. So we're going to shift it all the way over to 2. Shifting it all the way over to 2. Why? Because the phase shift is 2. Now the period length is 1. If the period length is 1, then we need to go have a period of 1, so that's going to be half to the left and half to the right. So that means that we are going to have asymptotes, 1/2 unit to the left and 1/2 unit to the right based on our phase shift. So basically we're going to have these asymptotes at the every other odd increment. So let's see. Better yet, let's count them. So 1, 2, 3, 4. There's another one at 1/2. 1, 2, 3, 4. There's another one at -1/2. 1, 2, 3, 1, 2, 3, 4. There's another one here. 1, 2, 3, 4. And obviously I'm drawing a whole bunch of periods here of this tangent function. So we shifted the whole thing over. This is where we're going to start, And since it is A is a -2, that means our branches will be decreasing branches. That's the easiest way to think about it. And remember, they're asymptotic. That's why they're branches. So that means we're going to go one back, and instead of going down 2 for an increasing branch, we're going to go one back, and we're going to go up 2, 1 over, down 2, because we're going to have a nice, tall, skinny, decreasing branch there. And basically, this same branch is going to be in between all of these other asymptotes, right in the middle. So another x-intercept there at 1, and then up, and then over. Remember, decreasing branches because A is equal to -2. We'll do one more. And we see it even going through the origin here because we just moved it over 2 units and the period is equal to 1. So the only thing that's changed here are the units on the x-axis. So there are 3 full periods of our tangent graph.